Miss Israel coming from Einstein High School. We are going to do Unit 1, Topic 3, Question 18. A scientist is studying bacteria growth. At noon, she puts one cell of Cranicus bacteria in a dish. I think that's how you say that word. After each hour, there are 8 times as many Cranicus bacteria as there was an hour before. At 4 p.m., she puts one cell of Bevis bacteria in a dish. After each hour, there are 32 times as many Bevis bacteria as there was an hour before. So we've got 2 different bacteria, so we're going to have 2 different functions for those bacterias. My little prediction for how this question is going to go. So let's see what we need to do. Part A, how many Cranicus bacteria will there be at 4 p.m.? Okay, I'm actually going to make a little table here, because I think that's always very useful. And notice I have 3 columns. So let's see, we are increasing by hours, so that's going to be our independent variable there. It's going to control how our functions increase. And then we have the Cranicus bacteria and the Bevis bacteria. So I'm going to say C of H and B of H, using a little function notation there. Okay, how many Cranicus bacteria will there be at 4 p.m.? So let's start at noon. And we started with 1 cell at noon. Okay, and we're increasing by the hour. So at 1 o'clock, and we're increasing by 8 times. So after each hour, there's 8 times. So I'm going to multiply times 8. At 2 p.m., if I keep going, that's going to be 64. If I do 64 times 8, at 3 p.m., we're going to be at 512. And times 8 is going to give us at 4 p.m. 4,906. So again, you can see how quickly those exponential functions increase. Okay. So at 4 p.m., we're going to have 4,906 bacteria. I also want to show you how we could have done that with an equation. Just like in the last problem, if we're increasing by a factor of 8, that's going to be y equals 8 to the power of x. Actually, let me rewrite that. I want to use our function notation since we're going to need that a lot later on in our unit packet. We have C of H, so how many Cranicus bacteria after H hours is going to equal 8 to the power of x. Okay. And so in that case, we want to know what C of 4 is after 4 hours, which is 8 to the 4th power, and we should get 4,096 if we did this correctly. So let's try it out. I get, well, let's see, 4 times 4 times 4 times 4, excuse me, ooh, wrong number, 8 times 8 times 8 times 8, 8 to the 4th power. Sure enough, we get 4,096. So the reason I did that, I want to show you 2 different ways to get to the same answer. The most efficient way is probably going to be that equation here, C of H equals 8 to the power of x. But notice we got the same answer with our table. So don't be afraid. There's always more than one way to get to the right answer. Okay. Part B, how many Bevis bacteria will there be at 6 p.m.? I'm going to extend our table a little bit here. So 5, 6, I have room, so I'm even going to put 7 on there. And we're going to start our Bevis bacteria. Now, notice that the Bevis bacteria started at 4 p.m. So we're actually going to ignore, I'm going to block this whole chunk out here. So we're really starting 4 hours later, okay? So we're going to skip 12 o'clock, 1 o'clock, 2 o'clock, and 3 o'clock, and she put one cell in at 4 o'clock. So we're going to put 1 here. It's a different color. Okay. And we're increasing by a factor of 32. So 32 times as many. So I'm going to multiply times 32. 1 times 32 is 32. 32 times 32 is going to give us 1,024. And that's 6 p.m. And just because I put 7 o'clock, I'm going to do times 32. We get 32,768. There's our answer. At 6 p.m., there will be 1,024 bacteria. Okay, and I want to show you how to do that with an equation. So we have B of H. Our base is going to be 32 in this case because it's a factor increasing times 32. And remember, we started 4 hours later, so we're going to do minus 4 to represent the fact that we have to get back to our starting point of 0 by subtracting 4. And if we plug that into our equation, we have B of 6 is equal to 32 times 6 minus 4, or 32 squared. And if we plug that into our calculator, 32 times 32, or 32 squared, is going to equal 1,024. So again, that's just another shortcut. You can complete the table, or you can write an equation. You'll see that in both instances we got to the correct answer. All right, let's keep going. All right. Let H represent the number of hours after the scientist put the Cranicus bacteria in the dish. And we already did that, didn't we, in our table? We used that variable H kind of intuitively. What does the expression 8 of H represent? Well, we already figured that out in part A. What did we say? That's going to be that we're increasing by a rate of 8. Look at me. I should have made these little H's up here. I'm going to fix that real quick so I can get it right. Let's see. Our 8 to the power of H. I should have used H instead of X. So we know that that is the fact that our Cranicus bacteria is growing by a factor of 8 each hour. Okay. Part D, what does the expression 32 to the power of H minus 4 represent? Well, we already answered that question too in letter B. Again, I think I changed this to an H there. That's what we should have had. And so that's going to be representative of the fact that the Bevis bacteria is increasing or growing. Let me use the same word as I did in the last one. By a factor of 32 each hour, and started 4 hours after the Cranicus bacteria. That's why we had to subtract 4. Just like on our table where we crossed out those first 4 hours. Okay. Fill in the boxes with the correct exponents. Okay, so we have 8 is equal to 2 to the blank. So we want to know what power of 2 is equal to 8, and that's going to be 2 to the 3rd power. 2 times 2 times 2 is equal to 8. 32 is equal to 2 to the 5th power. And sure enough, 2 times 2 times 2 times 2 times 2 is going to give us 32. You can check with your calculator if you don't believe me. Okay, part F. Solve the equation 8 to the power of h equals 32 to the power of h minus 4 to determine when the number of Cranicus bacteria will equal the number of Bevis bacteria. Just like in problem 17, we want to know when is the Cranicus bacteria going to equal the Bevis bacteria. And they've already written the equation for us, but we did write our own expressions in part A and B, if you remember, just like in part 17, question 17. So we're going to replace Cranicus with 8 to the power of h, and we're going to replace Bevis with 32 to the power of h minus 4. All right, and you're going to get sick of me saying this, but our first step here is to get like bases. We're solving exponential equations. I'm going to keep writing it. Like bases. What does that mean? Well, right now my bases are 8 and 32. So instead of 8, I'm going to use what we came up with in part E and write that as 2 to the power of 3. And instead of 32, I'm going to write that as 2 to the power of 5. And notice I'm bringing down the h and the h minus 4. Those don't disappear. You got to keep them with you. Okay. Now we're going to use the power rule to simplify this here. So I need to multiply my exponents. So I have 2 to the 3 times h equals 2 to the 5th times h minus 4. Notice my parentheses there because I need to use the distributive property. That 5 is going to be multiplied by both h and negative 4. Okay. Simplifying, I end up with 2 to the power of 3h equals 2 to the power of 5h minus 20. And now that I have like bases, I'm going to cross those out and rewrite my equation with just the exponents and solve. So we're going to get our variables to one side, our numbers to the other. So I want to get my variables together. In order to do that, I'm going to subtract 5h from both sides. End up with negative 2h is equal to negative 20. And my final step is going to be to divide both sides by negative 2. And I get h equals 10. And since it was a word problem, I'm going to come over here and say, after 10 hours, number of Cranicus bacteria will equal the number of Bevis bacteria. And that's going to be it for number 18. Join us for question 19.